Alright, welcome to Lesson 8, proving triangles congruent with angle, side, angle, and angle, angle, side. So this is our next and our last two ways to show that triangles are congruent. And here are two examples of what an angle, side, angle, and angle, angle, side look like. And again, I'd like for you to, in your group, kind of look at these pictures and come up with an idea of why you think that these work. So go ahead and pause the video and do that now. Okay, start off with the angle, side, angle postulate. It's kind of like the opposite of side, angle, side. It says that if two angles and the included side, so the side in between, of a triangle are congruent to two angles and included side of a second triangle, then the two triangles are congruent. So with our picture, we see that if angle A is congruent to angle D, AC is congruent to DF, and angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. So you see that AC and DF is included, it's in between our two congruent angles, so that's why angle, side, angle will work here. Let's go on to an example. Going to prove triangle ABC is congruent to triangle DBE using just this picture. So I want you to pause the video and with your group finish this proof. So go ahead and do that now. Okay, from the picture, number one, we see that AC is congruent to DE and AC is parallel to DE, so that's given to us. So our first one is a given. 2 says angle A is congruent to angle E and angle C is congruent to angle D. Now I know it's kind of hard to see and you might have had to kind of tilt your head, but what we have here is two parallel lines and they're cut by a transversal. CD is a transversal and AE is a transversal. And what happened is that we get two sets of alternate interior angles. So that's why those are congruent, because of the alternate interior angles. The last step says triangle ABC congruent to triangle DBE, and if we look at our picture we see we have an angle, a side, and an angle, so that's our postulate, the angle, side, angle postulate. Our last way to prove that triangles are congruent is the angle, angle, side theorem. Now if you recall, our three other ways to show were postulates. They were things that are assumed true. Now this is a theorem. That means that a theorem can likely be disproven. Maybe. We're not sure. This one's a little bit weird and it's kind of hard to see that it holds water, but it does. If two angles and the non-included side of a triangle are congruent to two angles and the non-concluded side of a second triangle, then the two triangles are congruent. Now that non-included side is very key. As you see in this picture, both of the non-included sides are across from the same angle that's congruent. That has to be the case. We see that B and U are congruent angles and that non-included side is across from them. If the picture were to look like this, that would not work. These sides would not be congruent. These triangles, sorry, would not be congruent because the angles don't correspond with the proper side. But this is the picture we have, so it makes it true. We know if angle A is congruent to angle T, angle B is congruent to angle U, and AC is congruent to TV, then we can say that triangle ABC is congruent to triangle TUV. That's the angle side theorem. So again, here we have a proof. We're proving that triangle ABC is congruent to triangle XBZ. And yes, this picture is exactly the same as before. So we can have shown that these two pictures are congruent using two different theorems. And the way that the proof goes decides which theorem needs to be used. So I want you to go ahead right now and pause the video and prove this. Okay. As usual, number 1 is our given. 2, we see that angle ACB is congruent to angle ZXB. So that is these two angles. And that is by the alternate interior angles again. Our next step says that angle ABC is congruent to angle XBZ. So we see that. Now we have to think back to what tells us that, and there's two angles across from each other. Two angles across from each other are called vertical angles. So that's by vertical angles. So we look, we have triangle ABC is congruent to triangle XBZ. We look at our picture, we have angle, and a side, and the sides corresponding to the same angle. So we can say that it's true by angle, side. And those are two proofs for angle, side, angle, and angle, side.